Okay, today we're going to be looking at the Pythagorean Theorem. Now, when we use the Pythagorean Theorem, we're only focusing on right triangles. That's the only time that we can use it. So if this is our right triangle, we start by labeling this side leg A, this side down here is leg B, and the hypotenuse will always be leg C. So for A and B, it doesn't really matter because those can be the same, but the hypotenuse always needs to be what A squared plus B squared is equal to. So as I just said, the Pythagorean Theorem formula that we're going to be using for this is A squared plus B squared is going to equal C squared. So leg A squared plus leg B squared will always be equal to leg C squared in a right triangle. So let's go ahead and look at an example of this. So example 1, we have our right triangle with 8 centimeters here, 15 centimeters here, and side C that we're solving for. So we know that C is the hypotenuse, so we know that we can do 8 is equal to A, 15 is equal to B, and C is equal to C in this case. So now we just substitute back up here. 8 squared plus 15 squared is going to equal C squared. So when we do that, 64 plus 225 is going to equal C squared. And you're going to get 289 is equal to C squared. Then when you take your calculator out, take the square root of both sides, you're going to get that C is equal to 17 centimeters. Now let's look at an example where we're not solving for the hypotenuse. So we'd be solving for our leg A or leg B in this case. So we have another right triangle. We have 10 up there as a hypotenuse, 9, and X. So in this case, C is going to be equal to 10, A is equal to X, B is equal to 9. So now we set it up the same way basically. X squared plus 9 squared is going to equal 10 squared. So x squared plus 81 is equal to 100. Then you subtract 81, you get 19. You take the square root of both sides. Then you get x is equal to, we're going to be rounding to 3 decimal places when we can. So 4.359. Now let's look at a tougher example here where we're working with a rectangle. So we have right here, we know that this is a right angle because it's all a rectangle, right? So we know that this right here is 12. The hypotenuse for both of the triangles that we see is 15, and we're looking for this side length x. So there's 2 ways that you can do this. You know that this x will be there because it's a rectangle. You know that those sides have to be the same. And same thing down here for this being 12. So now you can go about saying that you have x is equal to A, 12 is equal to B, 15 is equal to C, right? So now you set it up the same way that we've been doing with A squared plus B squared equals C squared. So now we can say x squared plus 12 squared is equal to 15 squared. So now when you simplify here, then you're going to get x squared is equal to 81. You take the square root. X will be equal to 9 in this case. So you can write 9, 9. So now let's look at a problem where we're given, so this is example 3. Yep. So now let's look at a problem where we're given that the sine of theta is equal to 5 over 13. So we're starting to incorporate a little trick here, right? So now we have our right triangle. With 5 over 13, right? So at this point, it doesn't matter which angle we choose to be theta, just for the sake of it, just because we're working with sine. You can either do the top or bottom one, but the hypotenuse will always still be the same as a 90-degree angle. So in this case, we're going to make this theta right here. So based off of what we've done with SOHCAHTOA, we know that sine will be opposite over hypotenuse. So in this case, we can label O, A, and H like we've done before. We know that the opposite side is going to be equal to 5. So this side length will be 5. We know the hypotenuse will be 13. So now we can apply the Pythagorean theorem like we had before. A squared plus B squared is equal to C squared. And now we do the two legs squared, and that's going to equal C squared, or in this case, the hypotenuse squared, right? Or 13. So now we can say 5 squared, and we're going to call the adjacent side A, 5 will be B, 13 will be C, right? So 5 squared plus A squared is going to equal 13 squared. And when you start simplifying, plus A squared is going to equal to 169. Then A squared is going to equal 144. You take the square root, you're going to get that A is going to equal 12. So we know that this will be 12. And what the rest of this problem is asking, now that we found that side, we can write the cosine of theta is going to equal adjacent over hypotenuse. So that's going to be 12 over 13. And it's also asking for the tangent of theta, which is going to be opposite over adjacent. So that's going to be 5 over 13. Or I'm sorry, 5 over 12. So now we have a new problem where we have to solve the triangle completely, right? So this will be example 4. So we're given our triangle right here. And we are given side right here, 24, and this is 30. And we're working with triangle A, B, C. So right now, to solve a triangle means that you find all 3 sides in all 3 angles, right? So what's missing here is side AB, angle measure C, and angle measure B. So we need to solve for these 3. So what we can do is we can make this our angle, our target angle right here, so theta, right? We're trying to find theta now. Or first, let's find the side length AB by using the Pythagorean theorem like we have, right? So A squared plus B squared is equal to C squared. So we know that 30 is our hypotenuse, and we know we're looking for our x value right here, right? We're looking for one of the legs. So we can call 24 is equal to A, x is equal to B, 30 is equal to C. So now we can do what we've done above. 24 squared plus B squared, or x squared, is going to equal 30 squared. And when you do this, you're going to get 576 plus x squared is going to equal 900. Now, when you subtract that, you're going to get that x squared is equal to 324. When you take the square root of that, you're going to get that x is equal to 18. So side length up here, AB, is going to be 18. So now our next step is doing what we've done before with trig ratios to find angles. So in order to find an angle, we need to use the inverse trig ratios, right? So in this case, we know that x up here is going to be 18 now. So now, right now, you can do this any way now that we have all 3 sides. But right now, I'm going to do it where we have we're working with 24 and 30. So 24, we can label again. X will be our opposite. 24 will be our adjacent. 30 will be our hypotenuse. So now we can go ahead and write out our trig ratio. Cosine -1 of adjacent over hypotenuse is going to equal theta. So now what we can do is type in, or substitute our values in. So the cosine -1 of 24 over 30 is going to give you, when you put that in, you should get 36.87 degrees. So that is our angle measure C, 36.87 degrees. Now we don't have to do trig again just because we have two angles of the triangle now. And a triangle has to be 180 degrees, and we know we're working with a right triangle, so one angle has to be 90. So you can do 180 degrees minus 90 degrees. That's going to give you 90 degrees again. But now you can subtract our angle measure C so we can find our angle measure B. So 90 degrees minus 36.87 degrees is going to give you 53.13 degrees. And that is how you solve for a triangle completely.